So, hello everyone, good afternoon. I'm here to talk to you about testing in Django and a little bit about testing in general. So we are at Pycon Island 2017. Welcome to the second half of the first day of fantastic talks and workshops. This is in fact my first time visiting Dublin, first time visiting Ireland, so I'm very excited to be here. My name's Anna. This is my Twitter handle, so get in touch if you want to. Leave me feedback, either in person or on Twitter. Either way, that's fine. I'll be happy. Surprise, surprise, I use Python. I've been writing Django apps for a while now. I do other things as well. For example, I'm one of the organizers of the PyLadies London group, so if you're in London, I'll be happy to see you at one of our meetups. I work as a senior software engineer at a London-based startup called Verve. And so I know it is a little bit late to ask at this point, because you know that the talk is going to be about testing and about Django as well. Nevertheless, let's do a quick show of hands. How many people know what Django is? That's pretty much 100%. So that's really good. It's like, whew. If everybody would have said it's like, no, I have no idea what's that, I'll be like, oh, sorry. Can't change my talk right now. Who works with Django on a day-to-day basis? A couple of people? Yeah? A lot of us are doing web dev. That's really cool. Right, so let's dive deep into the Django testing framework. And we're going to start with a trip all the way from the version 1.0 to version 1.11 to see how the Django test framework evolved. And we're going to talk about little stories that happened along the way. So about 11 years ago, sometime before getting Django out of beta and releasing Django 1.0, this ticket is created. Add unit test framework for end-user Django applications. And the ticket lists all the possible benefits of having an integrated framework for the end users to test their Django apps. There's one hilarious argument which says, as an added incentive, this is a feature that is present in Rails. So obviously we need to have it in Django. And that's how it all started. It started with a management command, test. At the time, it accepted pseudo paths. So you would have to do app.testClass.testMethod. We also get a test runner. A test runner is also a config variable that points to a function that runs your test. And that means that you can write your own test discoverer and test runner if you want to. The test runner would set up the test environment, and it would look for tests in files named test.py and models.py only. At the very end, the test runner would tear down the test environment and return the results. Now, the oldest thing on this slide is models.py. Why tests are held in models.py? If we're doing modern day Django, we're not doing that. Well, the thing is, 11 years ago, doc tests were very popular, and they were used to test the ORM a lot. So models.py was used as a place to keep model and application level tests, and everything else you would test in test.py. That's the way it was. Client makes its appearance as a basic, stateful, browser-mimicking stub that constructs requests, passes them to the views, and returns a response, bypassing all of the networking altogether by interacting directly with the WSGI interface. At its core, it's still the same client that we have today, it's just a more limited one. If you're writing your tests using PyTest standard unit test library, then you probably have heard about test case. Test case is an extension of the unit test case. It can load fixtures, clean stubby mailbox, initialize the client, do all sorts of stuff, and it also provides a couple of helper asset methods, which, by the way, are still available today. Version 1.1 comes shortly after, with a revolutionary set of HTTP methods. The client now is capable of doing put, head, delete, and options. Along with the test case, we also get another class, transaction test case. And this is where we need to make a clear distinction. What is the difference between a test case and a transaction test case? So the test case acts like a burger because it wraps each test into an atomic block. It enters a transaction, it runs the test does messy things to the database, and at the very end, the test rollbacks this transaction so that it can leave a clean slate for the next test. Because of that, the test case class will prevent you from issuing any commits or rollbacks on your database so that it can ensure that the final rollback will restore the database to its initial state. If you want to do transactions in your test, then you can use the transaction test case. The way it works, it will clean up after each test by flushing the database at the start of each test. And by the way, the previous version of the test case class was doing exactly that. It was flushing the database. Version 1.2. So Django now defines a new interface for test runners. We're not going to use functions anymore. We're going to have a class, and the class will have a method, run test, which will act as an entry point. And by default, Django provides its Django test suite runner. There's a very interesting bug that happened at the time. So the test runner returns the number of errors and failures all summed together. And what Django did, it would spit out this number as a sys exit. So what happens is, if you get 0 test failures, then this is a success. If you have 1, well, this is a failure. 42 will be interpreted as a failure as well. If you get 256, well, that would be a success. Because this is an 8-bit number, so it will overflow into a 0. And you can imagine that from experience, you can get more than 256 tests failing. And so Django updated it, and it will always exit with a 1 if you have any errors or failures. Explicit 0 for a success, and a 1 for a failure. Easy. If you have 256 failed tests, that is going to be a failure as well with the new fix, which is fantastic. If we take a look at the definition of the test runner, something changed in the version 1.2. And specifically, what changed is this new argument called failfast. It allows you to terminate your test run on the first failure, and it's quite handy. Ever since, it has been removed from the Django implementation because it is available in the Python unit test library. So it's just good to know that it exists. Django has support for multiple databases with a replication strategy. So you can have a primary database and multiple replicas created. And this is how you would configure that in your settings. So you have a default database and you have a replica. So if you configure a test mirror, then you're going to have some replication happening. Then I'm going to explain what is happening. But if you wouldn't specify the test mirror setting, then there won't be any replication happening during your test. Just the default database will be created, and you'll be testing just against the default database. And at some point later, settings will be changed. So if you want to do the same nowadays, this is how you should configure it. So what happens in reality? When the test environment is configured, a test version of the replica is actually not created. Instead, the connection to replica will be redirected to point to the default database. So as a your writes to the default will appear on the replica as well, but not because there's any replication happening between the two databases. It's just because they're actually the same database. 1.3, with the test case, now you can check if the query sets are equal and the number of queries that you're doing. We also see a split between the two roles that the client embodied, the role of manufacturing requests was turned over to the request factory, and obtaining the response was left to the client. The request factory became a part of the public documented API. So how do we manufacture requests with the request factory? It's actually very simple. You create a WSGI object with a set of WSGI and request attributes, like URL scheme, protocol, payload cookies, and all that stuff. And you just return this object. It just doesn't do anything else. It's probably the most straightforward class that just does one thing. Now, we've talked that, so at the time, doc tests were quite popular if you were developing Django apps. So in the beginning, doc tests seemed like a very great idea because you get both tests and you get both documentation. But in the long run, it became a nuisance to debug. It also became apparent that they aren't really good docs and they aren't really good tests. So that's why doc tests will be discouraged to be used in the future. And they won't be, no, I think they won't be discovered a little bit later, but generally discouraged starting with the version of 1.3. 1.4, the family of the test case and the transaction test case that we're already familiar with got an expansion pack. So now we get a simple test case and a live server test case. So a simple test case is lighter than the test case because it doesn't hit the database at all. It means there's no setup, there's no tear down of the database, there are no DB queries. A live server test case, on the contrast, is a bit heavier. It runs an HTTP server for you so that you can use a testing framework for your end-to-end tests. And it's based on the transaction test case. Version 1.5. So remember we talked about the transaction test case and its flushing strategy. Other test runners became popular at the time, specifically nose, and developers realized that there's a little bit of mess left by the transaction test case. So if you flush the database before each test, it appeared to not be such a good idea. So it has been changed to flush the database after each test. And let me show you what was happening. So if you flush the database before the test, you get the following sequence. You flush the DB, you run the transaction test case, then you want to run a test case, and right there in between, you actually get dirty state because it hasn't been cleaned after the transaction test case. What Django did, its default runner would always rearrange tests so that the test cases would always run first and the transaction test case would run last. So in this case, the transaction test case leaves a dirty state at the very end, but this is fine because the DB will be destroyed at the very end. In fact, the easy solution here is just to flush after each transaction test case, and so we don't get any dirty state, and our problem is solved regardless of what test runner you're using. 1.6, one more HTTP method. This time is going to be patch, and just to let you know, the list is not complete yet. So we're still going to see more features added to the client afterwards. But there are all different improvements that were added in version 1.6. So we get a new test runner that is able to locate tests not only in models.py and test.py. Just think about this is version 1.6. We were still doing test in models.py. But anywhere from the installed apps, as long as it matches specific file patterns. And the new discovery also means that we'll not have any test in models.py anymore, thankfully. Pseudo paths are removed. Now we can use real file system, dotted, or directory paths. This also allows running tests that are not inside a Django app listed in installed apps, which is great. And finally, doc tests won't be discovered anymore. So this is what I mentioned that this is going to happen later. So it happened in 1.6. We're saying farewell to doc tests. 1.7, so 3 versions before, Django introduced this library UnitTest2. UnitTest2 was a backport of the UnitTest features that worked with older versions of Python, because at the time Django was supporting Python 2.4, and so it had to vendor something if it wanted to use these features. In 1.7, Django drops the support for older Python versions, so now it can go back to the regular unit test library. At first, when live server test case was introduced, it was serving all of the static files as if it was running with debug equals true. From this point on, live server test case will serve only files from the static root, simulating the real production environment, something that you actually want to be doing when you're running your end-to-end tests. And if you want to serve any static files from your app, then you should use static live server test case. In 1.8, it's going to be the last update to the HTTP methods of the client. And do you want to have a guess what's that going to be? Somebody was following all of the HTTP methods. That's fine, I'll tell you, that's trace. This is going to be the last one, and now the client is complete. So the test case, again, let's talk about the test case and its burger strategy. So that was a really big performance booster. But a few other changes were introduced in this version to make it even better. So before that, what the test case would do is it would wrap each test into a transaction, and it would, once it enters the atomic block, it loads the fixtures, it executes the test, it exits the atomic block, so it rollbacks the database, and then it closes all of the database connections for the cleanup. And it will repeat this for every single test. So if you have like 2,000, 3,000, 5,000 tests, it's going to do this all the single time. Now, with the arrival of Django 1.8, before loading fixtures, it does the following. It enters one transaction which will be rolled back at the very end. So everything else, all your tests, all your like 2,000, 5,000 tests will happen in between, sandwiched in this one big transaction. That means that you load fixtures only once, and you use setup test data also a single time. So, and every other test is wrapped into its own transaction. So as I said, the benefit is just an amazing performance booster because we do a lot of the things that we kept on repeating all the time, we just do them once. 1.9, so whoever works on a fairly large project, and if you have a lot of tests, and you know that it takes quite a long time to get the results. Now we're using CI, so everything runs in the cloud, and you have to like kind of push it, and then you wait for about 20 minutes, and then you're like, oh, my test failed, I gotta fix this. So it's kind of like an ongoing thing. So what we usually try to do, we try to speed up our tests, and an easy way to do it is to parallelize our tests. So in Django 1.9, we finally get built-in support for parallelizing tests using Python multiprocessing module. In fact, Django test suite is parallelized as well. So how does it work? The test runner will spawn a number of workers. If you don't specify how many, it will pick up the max number of cores that you have. Each process gets its own database. Therefore, if you have 4 workers, then you're going to get 4 databases. The test discovery will build a test suite. The whole load of tests will be partitioned afterwards into chunks of test case classes. Workers will pick up these subsuits of tests and run them. And once they're done, they return their result, they report their results of this subsuit, and they pick up the next, and it goes on and on until it finishes up and returns the final results. If you're stuck with a version prior to Django 1.9, which is not uncommon, unfortunately, we still have 1.8 LTS, I think, then you can use No's multiprocess plugin. It's also using Python multiprocessing module. The main difference between Django's parallel and No's multiprocess is that you get only one database, and because of the shared state, you can get bizarre failures sometimes. 1.10 will introduce various speedups and improvements that is happening continuously with Django, but there's one little feature that I thought is kind of neat. These are the tags. You can now tag your tests, creating buckets of certain types of tests that you would like to run together, for example, or you would like to exclude from your test run. And probably looks familiar if you have used Nose, for example, the Atrib plugin or the PyTest markers to essentially do the same. And 1.11. So starting with the Python 3.4, unit test module adds a context manager called subtest. Now, a subtest will execute a block of code as a subtest. So, for example, what happens in this case? So the test won't exit on its first failure when in this case I equals 1. But it will try out all the values and report at the very end all of the results. Now, it is possible to do subtests when running tests in parallel in Django, and it will report all of the results correctly. So this is just like a neat feature, but it's quite handy if you're parallelizing your test. And the subtest probably looks familiar if you're using PyTest, because that's essentially PyTest mark parameterize, I think. So that's it. We're done with the history. We've touched on all the different topics. It was quite hectic, a little bit from there, a little bit from here. But let's see the flow of running a test suite as a whole and what happens when you run manage.py test. So let's split up the test bed into multiple pieces and analyze each one and see what happens under the covers. So first you invoke the command. Then, if we zoom in, there's pretty much a straightforward invocation. So what you do, you get the test runner, you instantiate it, you pass a bunch of options, and then you run the test. So let's zoom in what happens in this run test method. So the first line is setting up the test environment. And that will do a bunch of things. The main 3 key points is setting up a lockmem email backend so that all of your email is going to be sent and stored into a stub list so that you have easy access and you can inspect it if you need to. This is a very reduced email backend in its functionality. So the second thing, Django template render method is replaced by an instrumented test renderer. Because before rendering, what will happen, it will send a signal to let others know about all the different events. And that's how the test client actually knows some of the extra information that it's providing you while you're running your tests. And finally, it deactivates translation so that tests will respect your project set language. And these settings are pretty much rigid. They can't be configured from the outside. This is what Django does inside, and it's just like it will do it for everyone in any circumstances. Next step, after setting up the test environment, it will build the test suite. The heavy load of building the suite is done by the Python unit test library. Django extends some of its functionality by allowing you to specify tags, parallelize the suite, have a debug mode, and all the different things. It will build a suite of tests, and it is just an aggregation of instances of test case classes all collected in a single place. There's nothing more to it. The next step, you need to set up the databases. You need to run some checks. You run the test suite, so running tests is completely delegated to the unit test text test runner. And for the cleanup, you need to destroy all of the databases that were created. After that, you need to tear down the test environment. That's essentially the reverse of what the setup test environment did. You need to bring back your original email backend. You need to bring back your original test renderer and finally delete the state and clean the mailbox. Last step, it will return the results of the test suite by combining the number of failures and errors. And I think at this point, this line should be familiar to you. A quick recap on all the different test case classes and how they relate to each other to have a more of a visual representation. It's a big hierarchy where at the very top we have the simple test case, subclass by the transaction test case, which is ultimately subclass by the test case and live server test case, and finally we get a specialized version of the static live server test case. Now, simple test case, as we said before, is really, really fast because it doesn't interact with the database. It has access to the test client though, so you can use it as a slightly more advanced version of the default unit test case class. Transaction test case is not fast at all. It's going to be pretty slow, but it will allow you to do database queries and transactions. Test case is going to be faster than the transaction test case, but obviously not as fast as the simple test case, because it allows database queries, but it will restrict committing any transactions. So the live server test case will act as a transaction test case, and it will launch a live HTTP server in a separate thread for the other thread, from the other thread that's actually running your tests. And finally, the static live server test case is a specialized version of the live server test case that, in addition to everything, will serve all of your static files. Client is a very handy utility for testing Django apps. And the three core actors involved in this browser mimicking are request factory, client, and the client handler. And we've talked about the request factory having the most straightforward role. It just constructs the request, and it can also encode data for, say, your post requests. Client, on the other hand, performs more functions. So first off, the client is stateful. So it will retain cookies, enhance your sessions for the duration of the existence of the client. It also does a couple of other things. So I mentioned that when we are running our test and we are setting up our test environment, we get an instrumented template renderer. Well, the client is listening to the events, such as template rendered and request exceptions, so that it's able to get a list of templates and the template context and add it to the response object so that you can see it. It also adds a bunch of other things like the resolver match, the JSON, the client object is attached to it as well. It also handles redirects, and it can build a redirect chain that you can inspect later. Client handler. The main goal of the client handler is to return a Django HTTP response with a WSGI request attached to it. It can load middleware. It disables the CSRF checks, which can be enabled back if you need them. And it emulates, as close as possible, the server and the browser behavior. That's pretty much it about the client. We've talked about all the different tools that Django provides for testing, but what we need to think about is like, how do we make sure that our tests are of good quality? And Brendan today mentioned Zen and the Art of Motorcycle Maintenance. And if you've read the book, you know that it tries to answer the question of what quality is, and it's not an easy task. We're going to get a bit less philosophical, and we're just going to try to answer the question, how do we make our tests more reliable, future-proof, and fast enough? And there are some tools that can help us achieve this quality beyond our own understanding of what quality is. So let's start with something simple. Factory Boy. It has shortcut methods for creating models during test. It can generate random yet realistic data. It's a very good alternative to fixtures. For creating this random yet realistic data, it relies on another library called Faker. And Faker has a bunch of providers that, based on certain criteria, can create random data. And the important part here is the fact that every time you run your tests, you'll get different values. So there is a very slim chance that maybe Factory Boy will catch a bug for you that you didn't realize you have. And if this sounds interesting to you, I'd suggest looking into the Python's Hypothesis library. It's doing property-based testing, and it takes the idea of the random input to a whole new level. So the idea of property-based testing originally came from Haskell, from a library called QuickCheck. And Hypothesis is the Python implementation. I saw Dave recently mentioning that maybe there will be a Hypothesis for Ruby. If somebody's like using Ruby, it would be interesting to use that as well. So what do we have? What does it do? So Hypothesis is using a decorator given, and we're using it to inject randomly generated values into the test. And these values are based on specific strategies, similar to Faker providers. For example, in this case, it's the test strategy. So what happens is when we decorate our test with this given, it will run the test multiple times, roughly about 200, with all sorts of edge cases. So it will try to inject all the different data to try to see if it can break your test with some edge case that maybe you haven't thought about. Since Django is an established way of doing web in the Python world, as we have seen, pretty much everybody knows what Django is, and a lot of people work with Django on a day-to-day basis, Hypothesis comes with an extra module with support for Django. So, similar to Factory Boy, we can create models populated with random data. To be noted, if you're using Hypothesis, then you need to then the library will save the created models, so you can't just create them in memory. These have to be saved. So this is a real-world example of how Hypothesis can be used for testing Django apps. I know it's a lot of code. I'll start throwing away and like dissecting and going through it, so you don't need to actually try and read it out all. Just take a look at the very top at the imports. The most important line there is that we are importing from Hypothesis, we're importing a test case, because we need a test case that is capable of having like this 200 times, but not doing it in a single transaction block, but actually doing all of this 200 runs in a separate atomic block. So let's throw away the imports and focus on the code. This is a slightly stripped down version of a code example that I borrowed from a presentation made at the Django local user group in London, made by the author of Hypothesis. So what we are testing here, we are testing if a project model instance will respect the limit of users a single project can have. So you can say my max limit is 3 users, so I shouldn't be able to add more than 3 users to my project. So we're using the given decorator, and we inject one project model instance and a list of random amount from 0 to 20 user models. Then we check if the project is at its collaboration limit, and by trying to add another user. So if it's already at its limit and we're trying to add another user, we expect that there should be an exception to be raised. Otherwise, adding users should just work fine. And when running the test, if Hypothesis finds an example of data with which it can make your test fail, it will output something similar to this. So it's called a falsifying example. So in this case, a project has a limit of 1, but we were able to add 2 collaborators. So sorry, you have a bug. But here's the catch. Tests are best when they're very simple and dumb. One should not have bugs in their tests. And as you have seen in the previous example, that was a lot of code, and hypothesis tests can get a bit more complex, and you might even reach a point that maybe you would need tests for your test, which is not a good thing to have. But when used properly and timely, property-based testing can be a valuable tool. So just know it exists, and if you have a good use case for it, and you'll be like, I know what I should be doing. So the test code coverage is probably the most known and widely used metric. It's so easy to set up. All of us, we just have like code coverage, be like, oh, my code coverage went down, you should write more tests. Last time I checked, Django has roughly 75% of code coverage. If you run the test against SQLite, it should be higher if you try and hit all the other databases as well. But here's the thing. Test coverage is generally a bit deceptive. If you have low code coverage, then yes, you probably need more tests. But if you have high code coverage, what does this actually mean? Well, from the tool's perspective, it just means that you hit every single line of code at least once. It doesn't question what is the complexity of your lines and how well did you test it. So unfortunately, to me, high code coverage doesn't imply high quality of test, so I wouldn't rely on it. We can do better, and we can do better with mutation testing. Apparently, mutation testing isn't a new concept. It has been around since the 70s. What it does, it involves changing your code in some very small ways and observing what happens when you run the test against this changed code. This is a simple but powerful idea. In Python, we have different implementations available. There is MudPy, MudMud, or MuteMute, Cosmic Ray. They're different, and it's an interesting. It would be interesting to do a comparison between all three. For example, the MudPy and Cosmic Ray support Python 3 only. Mute supports, I think, Python 2, and they all have their own strengths and weaknesses. Depends on what you're doing. So, for example, MudPy operates on the Python AST to implement its mutations. In fact, I think the others as well. So here's how we can invoke it. So from the command line, you can invoke MudPy, and you say MudPy, you specify a target, which is which you want to mutate. This is your source code, and you specify a unit test that is testing this code. Say that your target source code has an if statement and a logical operand and. So you say if foo and bar, then this thing should happen. MudPy takes this logical operand and inverts it. So from an and, it becomes an or. So your target code actually becomes a slightly modified version, and we call it a mutant. And now we take our unit test and we run it against the mutant. So if the test fails on the mutant, then this is good. We say that the mutant was killed by our test. But if the mutant survives, then our test isn't good enough. Because if you think about it, you changed a bit of code and it didn't make any difference. Your test was still running okay. So maybe you're not even testing if it makes a difference, if it's an and or it's an or. And MudPy can do a lot more. There's not just that. There's a fairly long list of different mutations that it can do. It can replace arithmetic operands, operators, break continuous statements, conditional operators, constants, logical. It can even delete whole conditional branches, decorators, and do a lot more. This is what a stripped-down result of a test run looks like. You get a mutation score, which is a percentage, and you also can see the total amount of mutants that were generated, 88 in this case, how many were killed, how many survived, incompetent, timed out. And So I took this tool and I started playing with it against the Django tests and see what results I can get. So for example, the Django duration utils mutation score is 89. And this is a pleasant trend of the correlation between high code coverage and high mutation score, because the duration utils test code coverage is 100%, which is excellent, right? This doesn't hold true always. For example, Django encoding utils mutation score is 64%, which isn't too bad. It actually gone up. The first time I did the talk, it was 32. And when I redid the whole thing, I was like, oh, it's actually getting better, which is good.
28% after this.
Yeah, I know, right? But if you look at the code coverage, it's 100%, which is, again, it's perfect. Let's talk about the Django tutorial. I think that Django tutorial is excellent because beginners don't need to search the internet for articles or video tutorials. They can just go to the Django official page and it's just right there. You can learn it. So easy. And a whole section of the tutorial is dedicated to testing. In the Django world, testing is an integral part of developing an app. And I think this is what it should be. This is what frameworks should aim for. When I was in my second year at university, I discovered Django, and this is also the first time that I wrote a test. And you know why? It's because when I followed the tutorial and I created a new Django app, and I opened this folder, and I saw all of these files, and something caught my attention. There was a file called test.py. In fact, the tutorial explained the exact steps I need to take to write my first test. So a testing framework is a powerful tool to motivate people to write tests, especially beginners. There is a section in the Django testing tutorial called When Testing More is Better. It says that, well, yes, soon enough you're going to feel like your project is growing and the number of tests are just like, there's more and more of them and it feels like it spins out of control, but you just let them grow. When testing more is better. Indeed, but there's a trap in there. With the number of tests growing, the total test run becomes slower. So the Django gives you all the tools and encourages you to write very high-level tests without you thinking of the speed implications. So what happens is the speed of your test can suffer, unfortunately. And as we know, slow test, that means slow feedback loop. If you get a slow feedback loop, you have a slow development cycle, and it's a vicious thing. So that's why I have 7 tips on how to make your test be faster. And the number 4 will shock you. So use a fast and less secure password hash during tests. You can use MD5. This is what Django does for its own test. Use simple test case as much as possible. Stop there and think, do you need database queries? If you don't, maybe you can just use a simple test case. That would be a perfect example. Use setup test data, because this method will be called just once, which is great. And number 4, as I promised, is use mocks everywhere, which is obviously a joke. So just to make it clear, I'm not doing any propaganda for mocks. And what I want to say is there's nothing inherently bad about mocks in themselves. It's just if you use mocks to speed up your tests, then there's probably something wrong with the design of your app. Tests are good for isolation, not for speeding up tests. So be careful what gets created in setup. We'll talk about this a bit more. Don't save model instances if it's not necessary. And finally, isolate your unit test. So let's take the last 3 and take a closer look. So if you have this, which is a tight loop, you need to be able to recognize these red flags, identify them, remove or reduce. You need to be able to understand, do you really need 10 objects for your every single test that will be in this test case class. Instead of doing create like we did in the previous example, actually what you could do, maybe you can create an object in memory. And similar to that, you can use factory boy and use the build method or stub. The caveat here is that you can't always create objects in memory. Sometimes you have to save them. For example, when you have many-to-many relationships. So isolate your unit test from the rest of your tests. So your test suite might look something like this. It's a mix of like unity test and more of a functional and integration test, and there are like all the different flavors. What would be more useful and would allow you to create a faster feedback loop if you could separate the unit test from the rest, because you can run the unit test all the time and they're really, really fast. So how you actually do it is one way you could write the unit test using simple test case, or you can tag them with a special label if you're using Django 1.10. Even better, you can make them simple unit tests or PyTests, which have no idea what Django is, and just put them in a separate folder and just run them as much as possible. They're fantastic for that. Don't neglect functional and integration tests, because these are the tests that validate the contracts between our units, and they're equally important for us. So say your friend runs a little bakery business, and they hire you to help them to build an internal app. And what the app needs to do is to help them figure out what should be the correct VAT value for their products, because that can save some time for their accountant. So let's start with a very basic, naive schema where we get a product model and a product questionnaire model with a one-to-one relationship between the two. So the product questionnaire is the key to our VAT decision making. It's a little add-on where we define basic yes or no questions and build a decision tree to eventually land on a defined answer. Is this product a 0 rated VAT or is it a standard rated VAT? So we're imagining we'll need a view, we'll need a template, a model form, so the template will display the questionnaire, the answers will be saved on the model because maybe we want to rerun those calculations again. So in the same view, we would like to converge to a final decision and save it to the product model. With a known VAT, it's very easy to compute the price. So I'll be showing example code for different approaches to how we can solve this problem, where at the very top we're going to have our business logic and at the bottom we're going to have our test code. So solution number one, after we know that the form is valid, we check if the product is a biscuit, and if it is coated in chocolate, then we set the VAT to 20%. This is a class-based view, just because of its brevity. Don't want to start a flame war between function and class-based views. And I'm overwriting the form valid method so that I can inject this little piece of logic in there. As for the test, what we're doing, we're going to create a product model. We're going to make a request using our client that we've dearly talked about. We post a bunch of data, we refresh the product from the database, and we check if the VAT was set to 20. That is the very last line. In reality, we understand that the if-else is going to be much bigger because we can split it up into multiple methods, but the main point is that the entry point for this calculation is going to happen from the view. And for each branch, we will have one test, and each test will create a product object because it is impossible to create a product questionnaire without a product model. And we're going to repeat it for every single test. Now, to test each one of these items, we are also testing the URL routing of the Django, and we are interacting with the database. to eventually send an input to receive an output. And if you're thinking that you can remove the database interactions with mocks, this is a bad idea. Like, this is not the right approach to have, because I'm going to show you actually a better solution in the end. Now let's move on to something else. What if we take the conditional check and we move it to the model form? So now it is in the save method, so it's happening right there. If you look at the test, what we are doing is we are creating again the product model, we are instantiating the form, we are passing in some data, we are checking if the form is valid, we're saving it, refreshing the model from the database, and checking if the VAT value was set correctly to 20%. To test it, what we did, we had to interact with the database again, but we were no longer testing the URL routing of Django, which is an improvement over the first solution. So what we did, via the form, we sent the input, the answers to our questions, to receive an output. And the third and the last solution moves the entire decision-making into a plain, old, boring Python class. It has a method called calculate VAT, and it does exactly what it says. It can be a simple function. If you don't like classes, that'll be all right as well. The main point here is that we forget that Django is a web framework and not a programming language. Different constructs can live outside of the core Django components. The VAT calculator has no idea of what Django is, and it doesn't need to, because it's conceptually just a completely different thing. When testing, I'm not testing the URL router anymore. I'm not interacting with the ORM. All I'm doing is I'm sending an input to receive an output. And what we did here is called decoupling. Decoupling has various benefits. For example, reusability. What I can pull out the VAT code from this repo and just build a separate app that calculates VAT and helps others figure out their VAT values. Extensibility. If my friend extends their business in a different country, and this country has different VAT rates, different logic of calculating this, then I don't need to try and find it and sprinkle it everywhere. I just have one single place where I can update it, the VAT calculator. And finally, the testability that we saw. This approach of isolating business logic allows creating more and faster unit tests and keeping the functional integration and end-to-end tests at a manageable rate. Tests have more in them than we think. A test has the capability to drive a better app design. In terms of Django, it's about moving logic away from any Django-related components. If it's a behavior that is not tied to your template or database or forms, views, then just build objects that perform these things and just keep them separate and unit test them. Happy testing, everyone. Thank you. I'm really, really sorry for holding you for such a long time.